Good day, ladies and gentlemen. You're welcome to the lecture number 4 on Buad718, which is Computer in Organization. I would like to begin this lecture by revisiting our course contents, which we know has 14 contents. And if you look at the content here so far, from lecture number 1 to lecture number 3, we have covered these items from number 1 to number 7. So which means we already covered half of the lecture in our previous 3 lectures. So today we are going to proceed from item number 8, and we'll continue up to the item number 10. So in this lecture, we start looking at the programming process. That is, I told you from my lecture number 1 that the computer is a programmable device. That is, for it to operate, it has to be programmed. And I told you a program is a set of ordered instructions that guide the computer on how to operate. And the process of developing those set of ordered instructions is what we call programming. So if you want to carry out programming of computer, there are some steps that are taken, and these are defined under this section. Number 1 is problem definition, then flow charting and decision table. Now, whenever you want to write a program, basically we have 5 major steps that must be taken in order to accomplish that task successfully. And item number 1 is defining your problem clearly. That is, you have to clearly tell the computer or define what problem you want that program to solve. And after defining your problem, the next thing for you is to plan for the solution. And this planning for the solution is used or is done using some equipment or some facilities. One of them is called a flow chart, the second one is called a pseudocode, and the third one is called a decision table. And as you can see, this item number 1 and number 2 are the ones that are expected to be covered under this item number 8 of our lecture. And after this, you go to the step of coding, and this coding is nothing but writing the actual computer program in a given programming language. We have seen previously that we have many programming languages like C, C++, assembly language, Java, and the rest. And after writing your program, you now come and test the program, and this testing is done using like 3 steps also. One of them is called the checking, the other one is called translating, and the other one is called debugging. And the last thing of the 5 steps of programming is documenting your program. But as you can see under item number 8 here, our concern is limited to the first 2 items, which include defining the problem and planning for the solution. Now, let us start with the first item, which is defining the problem we want to solve clearly. And how do we define a problem? For you to define the problem, first of all, you need to clearly identify what you know. What you know, as far as programming is concerned, is the inputs that you are going to deliver to the program. And you also need to determine what you don't know. What you don't know is what you want to obtain, and that is the output you want that program to produce to you after taking the input and processing it. And after that, you do processing. And what we call processing is the intermediate action that is taking place between the taking of the input and production of the output. Then, this is what we call defining problem clearly. So after defining your problem, As we have seen, under those 5 items needed for developing a computer program, we have what we call planning the solution. And for you to plan the solution, we use 3 helping tools. One of them, as I told you, is called a flowchart. The other one is called a pseudocode, and the last one is called a decision table. As we can see here, this planning of the solution can be done using either drawing of the flowchart, or writing what we call a pseudocode, or using what we call a decision table. So these 3 items, we are going to discuss them one after the other. Let us start with the first one, which is flowchart. What is a flowchart? A flowchart is nothing but a pictorial representation of a step-by-step solution to a problem. That is, whenever you want to write a program, as we said, you need to define your problem to know what are your inputs and what are your expected outputs. Now, those steps you are going to take in order to change your inputs to produce output is represented now in a pictorial diagram, and that diagram is called a flowchart. And also, this flowchart consists of arrows representing the direction of the flow of the diagram. Those arrows are showing, okay, from this step you go to this, from this symbol you go to that. And also we use boxes, and these boxes, they represent different actions that are taken in drawing the flowchart. And for us to understand this clearly, let us look at those boxes, those symbols we use in writing or drawing a flowchart. The first of these boxes or symbols is called a rectangle. As you know, this is the symbol of a rectangle, and this rectangle is used in writing flowchart for processing. What we mean by processing is doing something. That doing something can be addition, can be subtraction, can be multiplication, can be print, can be anything. And if you look at this in writing a flowchart, the rectangle always have 1 entry point and 1 exit point only. Then after the rectangle, we have what we call a diamond, and this diamond, as you can see from this diagram, it is used for taking decision. And as we know, whenever you take a decision, your answer should be either yes or no. That is, you either accept it or you reject it. So if you look at your this diamond, it has 1 entry point, and this entry can come from any other block. It can come from rectangle, it can come from parallelogram and others. And it has 2 exits. One is for the yes when the decision is true, and the other one is for no when the decision is false. Then the third one among these symbols we use for writing a flowchart is called a connector, and this connector is a cycle. The function of this connector is to connect different points that are coming from different blocks, but they are going to the same point. So they will come to the cycle, then this cycle will deliver them to the point where they are supposed to go. So for this, we can understand that our connector, which is a cycle, can have many entries. Here we represent only 2, but it can have as many as possible, and it has only 1 exit. Now, the symbol number 4 in drawing a flowchart is called oval, and this oval, it is used for doing 2 things, either for starting a program or for ending a program. When the oval is used for starting program, you can see that it has only 1 exit, but it don't have anything like entry point. And when it is used for ending the program, it has only 1 entry without exit. Then the symbol number 5 when drawing a flowchart is called a parallelogram, and this parallelogram is used for 2 things, either for taking an input or for producing an output. And as you can see from the diagram, it has 1 entry point and 1 exit point. And lastly, we have the arrows I have mentioned earlier, and these arrows, as I told you, they are used for showing the direction of the flow of the program. And you can see we have 4 arrows, 1 pointing down, 1 pointing up, one pointing left and the other pointing right, which means the flow can be in any direction, up, down, right, left. Now, ladies and gentlemen, these are the 6 basic symbols that we need to know and understand their function if we want to draw a flowchart for a computer program. And for us to understand how this is done, let us start looking at worked examples. Here we start by looking at the worked example number 1. And what this example says we should do is this: draw a flowchart for a program, and that program will be used for finding sum of the first 50 natural numbers. We want to develop a computer program that will find the sum of first 50 natural numbers. So now we want to plan our solution by using a flow chart. Okay, now the first thing we'll do is to start the program. And as we know, the oval shape is used for either starting or ending a program. So I'll write my start here and the arrow will come down, because for starting we have exit from the oval. And because we are told to find the sum of 50 numbers, before we take the first number, we have to initialize our sum. That is, our sum is equal to 0 when the number taken is equal to 0. That's, we did not take any number. The next thing now is to increment your number, that is to take the first number, so that your new number should be equal to the previous number plus 1. That is, in this case, our previous number is 0, then you take 1. After taking 1, you now come and say your sum, that is the new sum, is equal to the original sum we have plus the number we have just taken. Yes, we know this is the first number we have taken, but nevertheless, since we are asked to limit the summation to only first 50 natural numbers, then we have to come into decision and say, is the number we have just taken equal to 50? If it is equal to 50, it means we have satisfied the condition for summing 50 natural numbers. If it is yes, then it will go to this parallelogram, which is used for what? Producing an input or an output. So in this case, we'll say print sum, which is producing an output, and then it will end. But as you know, if it happens that the number we have taken here is only 1, so when you come to the decision box and say, is the number taken equal to 50? Of course it is not equal to 50. Then it has to go back here and take another number. It will keep on taking numbers until when it finds that yes, the number it has taken lastly make the total of them to be 50. In that case, it will go and print the sum and end the program. So let us try to understand this very well. Let me say it once more. We are asked to draw a flowchart that can be used to show the procedure of writing a program, and that program is expected to find the sum of the first 50 natural numbers. Okay, so whenever you want to write a flowchart, you start the program, and we said we are using oval shape for starting. Then after starting, you now initialize. Initializing is to say that your original sum is equal to 0. Whenever you say something equal to something, you are doing processing, and as I told you, the processing is done using a rectangle. And then you now come and initialize the numbers. Before you take the first number, definitely the number is equal to 0. Now you go and say, let's increment the number by 1. That is, let us take the first number. That is, your n is now equal to n plus 1. And now you go to your sum and increment it by the value of that number you have just taken, so that your sum will be equal to the original sum plus the number you have taken now. After that, you have to go and investigate whether you have reached the 50 numbers. Of course, since we have just taken one now, if you say is n equal to 50, of course it is not. Then it will go back here, take another number, add it to the summation, go back, take until when it say okay, n is equal to 50, which means we have added all the 50. And if that happened, we'll now go to produce an output. And we know that a parallelogram is used for producing output. And after producing your output, you end the program, and we end by using an oval shape. Now let us look at another worked example, which is worked example number 2. We know that example is better than precepts, so let us take example number 2 so that it can help us to really understand the concept very well. And this example is saying we should draw a flow chart for a program that will read temperature of room. When it reads the temperature of the room, it will put on, that is, it will switch on AC when it found that the temperature is less than 25, above 25% rather, at 25 degrees Celsius, sorry, and it will put off the AC otherwise. That is, whenever it detects that this temperature taken is not above 25% degrees Celsius, it will now switch off the AC. Okay, so look at the requirement for this program. First of all, we should read temperature of a room, and if the temperature is read, it will now be compared and see, is it above 25 degrees Celsius? If yes, it will go and do one work. And what is the work? Putting on the AC. But if it found that this 25 degrees Celsius, or the temperature is less than 25 degrees Celsius, it will do another work. And what is that work? That is to put off the AC. So in order to solve this problem using a flowchart, as usual, we use an oval shape for starting our program. Now, after starting the program, the next thing you will do is to go and read the temperature of the room. Whenever you are reading a data, it is like you are taking an input. For this, we have to use a parallelogram, because we said the parallelogram is used for taking an input or producing an output. Now we read the temperature. Having read the temperature, we'll go to decision box to ask, is this temperature greater than 25 degrees Celsius? If yes, we are told that we should go and put on the AC. Putting on the AC is a processing, is doing something. Therefore, we have to use a rectangle. After putting on the AC, then it will go to the end. But if this decision is temperature greater than 25 degrees Celsius, if it is not, then it will put off the AC and it will go to an end. This example is very simple if you look at it very carefully. So let us look at worked example number 3, which I think should be the last worked example we are going to consider here. And what it says is that we should draw a flow chart of a program. That program will be used for counting the votes which are casted in an election, and that election has many candidates. Then after counting the votes, it will eliminate all other candidates except 2. The candidates are many, as we said, but it will eliminate all the others and leave only 2. And that's those 2 that were left. The program will now look at them and say, okay, this one has higher votes than this, then you say this is the first candidate and the other one is the second candidate, and we represent them as A and B. So let us look at how this problem is solved using this flow chart. Now, as I told you, for a flow chart, we always need what? A starting point, and we use oval shape as usual. Now, after that, it will go and do what we said we should do, that is counting the votes. So, read the votes casted. Now, reading the vote is like accepting inputs. Okay, now, if it reads all the votes, now it will now start reading the voter's first choice. That's after accepting all the votes, it will now be checking and say, okay, this is the first choice, I place it here. This is the first choice, I place it here. And this first choice should be for what? The many candidates we have in the election. Then after it does that, it will now come and say, okay, Are two candidates left? Because it has taken the first choice of all the contestants, I mean the voters. Maybe we have 10 and each one has a number he has got. Of course, when it read for the first time, definitely all the 10 candidates, if for example we have 10, they are there. Definitely the answer should be no. So if it is no, it will now go and eliminate the last candidate. That is the one that has the smallest number of votes should be discarded. And whenever you are discarding something, it's like you are doing something, it's an operation. That is why we have a rectangle. After discarding it, it will go and recount the votes of the remaining candidates. Counting the vote for the remaining candidate is also an action, doing something. That is why we use a rectangle. So after counting, it will go back to that decision box and see, are two candidates left? And of course, if we go by my example that we have 10, we have eliminated one, right? Definitely now we have 9. So therefore, the candidate left are not 2. To go and eliminate the next one, reducing them to 8, then recount. It will continue doing this until only 2 candidates are left. And these 2 candidates, it will call them A and B. So now it will go to another decision box and say, is A greater than B? If A is greater than B, it will now come and print A is the winner. And I'm sorry, this box, since it is printing an output, is supposed to be a parallelogram, but I made a mistake. I used a rectangle, so you can correct it. This box is supposed to be a parallelogram because it is producing an output. But if it found that A is not greater than B, it means B is greater than A, then it will now come and print B is the winner. And of course, this one is supposed to be parallelogram also. And after printing B is the winner or A is the winner, of course it is going to the end. That is why we are using a connector here, so that both of them will go to the same ending terminal. So ladies and gentlemen, as we have seen, this is the procedure of drawing a flowchart or a computer program. If you look at these examples, definitely you find that it is not that very difficult. All you need to do is to take your time, watch it and watch it again. You will definitely understand. And now we go to the second item that is used for planning solution to a particular program we want to develop using a computer programming. This second item is pseudocode. This pseudocode, the word pseudo simply means not true, not real. And this code is the program. So if we say pseudocode, it means not real computer program. So for this, we write it in English like manner. It is an English like non-standard programming language. You write it just as you are writing English because you are planning. It will help you to know, okay, do this, do that to the end. So if you see the procedure, then you can come and write it in the real computer programming language. Why do we use it? We use this one to permit us to focus on the program logic, not the syntax, not the actual technique of writing the program. To know after this step, what next, what next. That is why we use a pseudocode. Number 2, it also helps us to omit the essential details for machine understanding. Because for you to write a code that the machine will understand, you have to use real programming language, after which you compile it. But here you are writing it for you to see the picture of what you want to do, because we are at this planning stage. Then the next one, the purpose of using this pseudocode is that it is easier for common people to understand, whether they know programming language or not. And then this programming language is not executable. That is, if you load it into the computer don't know what you are doing, therefore it cannot execute it. It is just for you to see the procedure of the logic, so that to detect if there is anything omitted, make correction, and then go to the real programming codes using a particular language. And we should know that there is no standard syntax for writing pseudocodes. Different people use different format for writing their pseudocode. Unlike the flowchart we have seen, where all these boxes, all these symbols They are uniform for everybody, but for the pseudocode, no standards. Now, for this also to be understood, what we'll do is to look at worked example. And we start from worked example number 1. And it says we should write a pseudocode for a program. That program will read numbers from 1 to 100. And it will print even numbers and odd numbers. That is, it will read from 1 to 100. If it read the first one, it will find out, is it even? Then print even. Is it odd? Print odd until it reaches hundreds. So for us to write our pseudocode, this is the solution here. First of all, we give it a heading, and that heading is just to tell the program what it will do. And we said program even odd. That is a program that we are going to use for identifying odd numbers and even numbers and printing them accordingly. So we are also asked that we should do that for the numbers from 1 to 100. So we'll now come and say do I. This I stands for the number of iterations. That is, you will do this from 1 to 100. That's 100 times. Then it will now start reading numbers from 1 to 100. Then if it read the first number, it will say if the first number taken is divisible by 2, then it will go and print even. But if it is not divisible by 2, it will now come and say if that's the number taken, is not divisible by 2, it will go and print odd. And after doing that, it will end the do, because the do, we said it should do it how many times? Up to 100 times. That is, it will be taking 1, check, is it divisible by 2? Print. Is it not divisible by print odd? It will keep on doing until when it's reached the 100, then it will end the do, and that's the ending of the program. Let me also take time to repeat what we said. When writing a pseudocode, the first thing you need is to give it some to give it a kind of heading, and our program will read numbers and classify them into even and odd. So what we'll do is to say the program is called even odd. That's the name we give it, and we are asked to read numbers from 1 to 100. So we now say, let's assume our number we are taking, each one is called I. So we are saying take this I from 1 up to 100. So the first thing it will do, it will take I equal to 1, and it will come to this decision level, that is if, and say if that I taken is divisible by 2, then if yes, it will go and print even. If it is not, then it will come to this decision and say, is it not divisible by 2? Yes, it is not. Then print odd number. After doing that, it will go back and take the second number, do the same thing, go back and take the next number, do the same thing until when it finds that this I is equal to 100, now it will end the process. Let us look at the second worked example under the pseudocode. And the example says we should write a pseudocode of a program that will read the temperature of a room and put on AC when the room temperature is above 25 degrees Celsius, and it will put off the AC when the temperature is not greater than 25 degrees Celsius. And that's what it means by otherwise. You can remember that we use this example under the flow charting. So for us to solve this problem, we start the solution as follows. We give the program a heading. We call it program temperature control, because putting on AC and switching it off is like you are controlling the temperature of the room. So the next thing is you should go and rate the temperature. Then you come to the decision and say if temperature is greater than 25 degrees Celsius. If yes, then the action is switch on the AC. But if it is not greater than 25 degrees Celsius, it will now come and say if temperature is less than or equal to 25, which means it is not greater than 25, then switch off the AC. This off is supposed to be double F, and after that it will end it. Very simple. Pseudocode is very simple. Now we go to the next item among the three things we use for a planning solution when writing a program, and that is decision table development. This decision box, table, is used for modeling complicated programming logic. That is, whenever we are given a program that is somehow complex, so we need a decision table to help us simplify it. And this table will help us to make the process very easy. How? It will help us to see all the possible combinations of the conditions excuse me, that need to be considered in order to write the program correctly. And that decision table will also help us to see whether any necessary condition is not included. If yes, then we have to incorporate it for us to avoid errors. And these tables, they have 4 parts. The part number 1 is the conditions, the part number 2 is for the actions, and the part number 3 is the alternatives of those conditions. And those alternatives for each condition, we call them rules, and they are placed in the columns of the table. And the last one, which is number 4, is the action for the rule. Action for the rule. That is, if we get the rules, what actions do we take on them in order to implement them? Now, the procedure we follow for creating a decision table includes these 6 items. Number 1, we identify the conditions and their alternative values. That is, all the conditions, we identify them and we say, okay, condition A, what are the alternatives? Condition B, up to the last one. Then the next thing is we should compute the maximum number of rules, and we are going to see how to calculate the maximum number of rules with help of example. And the next, we identify the possible actions, and the next one, we define each of the actions to take given each rule. That is, this action should be done under such rule and this action under this rule. And it also helps us to verify that the actions given to each rule are correct. This is the step number 5. And finally, after doing all this, you come and simplify your table. And as I said, let us look at worked example. It will make life very easy for us to understand. Now, the worked examples say, draw a decision table for a program that will be used to store and process data of population of a city. And that city population is going to stored and processed based on the gender. And in gender, we have 2 alternatives, male or female, and with respect to the age. And in this age, they are categorized into young and old, and the income level of the people. And here we have 3 categories: low income, average income, which is medium, and then high income. So since we use average, let's put A here. So the solution, the first thing we'll do is to get our conditions. The conditions is that we are going to store and process the data based on 3 conditions here: the gender, the age, and the income of the group. These are our conditions. Then the next thing is we should put these 3 conditions as 3 rows from the upper part of our table, like this. These are the conditions: gender, age, and the income. They are put here as our rows at the top of the table. And then the next thing is gender's alternatives. As we know, we have male and female. The age alternative, we have young and old. And the income alternative, we have low, average, and what? High income. So if you look at this, here I have 2, here I have 2, here I have 3. So if you want to determine the products of these numbers to serve as your rules, you will now say 2 for the gender, 2 for the age and 3 for the income. 2 times 2, 4 times 3, it will give you 12. Then level each column using 1 to 12, and this corresponds to the total number of rows we have. And that's why you can see here I have 1, 2, 3, 4 up to 12 standing, based on those numbers. Now after doing that, you come to the gender. You can remember that gender, we have how many alternatives? 2, either male or female. So you keep on putting them alternatively, male, female, male, female, male, female, up to the last column. Then if you come to the age, we have 2 alternatives, either young or old. But in this case, you should be repeating them twice. That is young, then old. Young, old. Young, old. That is how you do it. And if you come to the income, we know we have 3 alternatives: low income, average income, and high income. So this low income, you put it 4 times, the average income 4 times, and the high income 4 times. That will give you the total of your 12. So after doing this, you can examine this table and say, okay, for example, the first column, this column, it is given us a condition that there is every tendency you can get a female who is young and has low income. And also, if you look at rule number 2, you can get a male who is also young and who is low income, a person. And law number 3 is saying we can have a female who is old and has low income. So these are the combinations until you have all the 12 like that. So ladies and gentlemen, if you look at this is the brief on how to draw a decision table. We identify our conditions. Our conditions are 3 here: gender, age, and income. And we know the gender has 2 alternatives, the age 2 alternatives, and the income 3 alternatives. Now we multiply those alternatives 2 times 2 times 3 to give us 12, which give us these our columns, while our conditions are here. And we said for the gender, we should be putting male, female in alternation. And for the age, we'll be putting 2 at the same time: young, old, up until you reach the end. And for the income, you put 4. And if you understand this, it is like you are taking 2 raised to power n. Here is the first column, 2 raised to power 0, 1, which means we are putting 1 in alternative. And here 2 raised to power 1 is 2, you should be putting 2 in alternation. And here 2 raised to power 3, because it's the third row, so we now say 2 raised to power 2, which will give us what? 4 in alternation. So now we go to the introduction to basic programming. The computers, as we said, they are very useful because they can be used for storing data, and they can be used for manipulating huge amount of information. So that information that we can store in the data, it can be numbers such as financial reports. You have so million in the bank, so in the company, like that. And the data, it can be alphabetic in nature: A's and B's, A, B, C, small letters, capital letters underneath. Like the names of people and addresses, they all use alphabets. And also the data sometimes can be in form of image, sometimes it can be in audio, that is a sound, and sometimes it can be visual, that is a picture image. So now, managing this data in the computer, it requires programming languages, because we define computer as an electronic device which is programmable. By programmable, we mean it must be given a set of instruction on how to work, and that is actually what we call programming. And of course, we have different languages that we use for writing computer program, and some of them are C, programming language, C++, C#, Java, Ada, assembly language, Basic, COBOL, Fortran, and of course there are many more. So since we said the computer manipulates data, So what are the data types we have when writing a program to the computer? The data we have in a computer when writing program are categorized into two. We have what we call variable and we have what we call constant. Now, what is a variable and what is a constant as far as computer programming is concerned? We know a data in a computer is stored in the memory of the computer. And this memory is a space in the computer which contains uniquely numbered cells. It has different cells and each cell has a number, and that number is called the memory address. That's the address of that memory slot. So then with this we define a variable as a name of that memory space which is reserved for storage of data. Therefore, variable is nothing but the name of the memory space which is reserved in the computer so that you can store any data. And of course, if we call it this, it means whenever you reserve a place, nobody will tell you what you should put there. All you know is that you know the address. You can place letters, you can place figures, you can place image, anything. That is why it is variable, because it can handle anything. Variable is nothing but the name of the memory space that is reserved for storage of data. We come to variable names because we said they are reserved spaces, then they have to be given names. Now, the variables you want to define, in any case they must have name. That's first thing, they must have a name. You have to give them a particular name, and of course you have to define what type of data are they going to store. So with this we go to the point of looking at some rules that we must follow in giving a proper name to a variable. What are the rules that we must follow if we want to give a name that is acceptable to the variable when writing a computer program? Rule number one is that the variable name must start with an alphabet. It must start with an alphabet, and it can contain other underscores, the symbol underscore, and it can also contain digits 1 2 3 to 9, 0 1 2 3 to 9. And also another rule is that we can use uppercase and we can use lowercase for naming a variable. And the rule number 3 is that there should not be any space in a variable name. Supposing you have a variable name, don't leave a gap. Even if it contains so many things, make sure that they are matched together. And the rule number 4 is that we should make sure that there are some words that are called keywords. The computer is using them for specific purposes, therefore they should not be used for writing a variable name. Such words include int, which is for integer, float, which is for plotting point number, if, which is for condition, while, which is also for condition. These ones and the similar ones, they are called keywords and they should not be used in writing a variable name. Then the rule number 5 is that the variable name should not be very long. We are not told that it has to contain so number, but there is a rule that says the first 8 characters of the variable name are very significant, meaning when you are writing, try to make it like minimum of 8 characters, but it shouldn't be very long. Now, have a look at the rules for writing a variable name. Here we give some examples of variable names which are acceptable. Supposing you say f amount is a name of a variable, a space reserved, no problem, it's accepted because it starts with a capital letter, alphabet, and there is no gap between them. If you look at this one, it's also accepted. It starts with an alphabet I and there is no gap. Also this one, it starts with J, counter, no space. They are all valid variable names and they are acceptable. Now we said when defining a variable we have to define 2 things. One, the name of the variable, and the second one is the type of the variable. So let us look at the data types we have. The data types in computer are divided into two. One type is called primitive type and the second one is called a reference type. So the primitive types, these are the types that are generally known and nothing can be added to them. They are all known and they are generally 8. We have what we call a boolean, we have byte, character, short, long, integer, float and double. These 8 are what we call the primitive types and nothing more, nothing less. But when you are writing them in a computer program, instead of writing boolean like this, we use a small letter here. Instead of writing byte here, we use a small letter. Instead of writing character in pool, our C should be small letter and we terminate as R. Short, small letter. Long, small letter. For integer, we just write int. Our I is small letter. For float, F small letter. For double, D small letter. And they have range of values that they cannot go beyond. For instance, if you say you are using boolean, this boolean is just for decision making, and whenever you're making a decision, it's either to get a true, false, or to get a false answer, that is to get yes or no. So the variable, the possible values for this boolean is either true or false. But if you did not specify that this is true or false, the computer program will take it as false. That's the default value. Then for the byte, it has values from -128 to +127. But if you did not assign any value, it will assign 0 to it. And for the character, it has values from -128 to 127, but using the ASCII code we have discussed. And the default value is 0 when you did not give any value. But for the short, it has -32768 to 32767, and the default value is also 0. For the long, it has from minus this to this, the default value is 0. And for the integer, it has minus this to this, and the default value is this. And also for the floating number, this floating number is nothing but expressing the number in scientific form or in standard form, that is something point something 10 times 10 raised to power something. Like this, we have 3.4. This E means exponential, times 10 raised to power minus 38 to 3.4 exponential 10 raised to power 38 positive. And if you did not specify the value, it will give you 0.0f. And for the double, it is also a scientific form, 1.7 times 10 raised to power minus 308 to 1.7 times 10 raised to power 308 positive. If you did not give us a value, it will give you the default, which is 0.0d. Now, how do we declare an integer variable in a program? Supposing we have a variable, but its type is an integer. How do we declare it in a program? That is to tell our program that this is a variable and it is of integer type. So what we'll do, first of all, we will say int. Writing this int is telling the computer that whatever you are seeing is a variable and it is what? Of integer type. So here we say int, which is the type. Then we say I. This I is the name given to the variable, and we now initialize it to say that the value of this I is equal to 20. So what we did here is to tell our computer program that what we are going to deliver to you now is of integer type, and we give it a name I, and its value, initial value, is equal to 20. So here we have initial value of 20. But if you wish, you can say int, that is telling the program that what I'm about to give you is a variable which is of integer type, and the name I gave to it is number 1. And if you look at this, is a valid variable name because it consists of alphabets and what? Figures, and there is no space between them. And if you look at this, we just say that integer is called number 1, but we did not give it any initial value as we give 20 to this one. And if you look at the end of writing this, we have a semicolon. This semicolon is to tell the computer that this is the end of the statement. If you want to declare the long, and the shorts. You declare them just like we declare integers here. You can declare them with initial value or without initial values. Now let us declare a double, a variable that is of double type. So one way to do that in the program, we write double. This double is identifier that is telling the program that our variable is a double type, and we call it I. This is the name we have given to it, because we said whenever you are defining a variable, we have to define two things: the type and the name. Here we said it is of double type and its name is I. And also here we give it an initial value. We are saying its value is 2.124 times 10 to the power minus 5. Here we define our integer with the name I, and it is of double type and it has initial value of this. But if you wish, you can say double number 1. You are saying the variable name is number 1 and it is of what? Double type. But here you can see we don't have any value given to it, therefore we declare it without initial value. And the way we declare this double is similar to how we declare a floating number, because if you go back to the table, you see that the floating and the double, they are all in scientific form. That's a standard form. Now, how do we declare a variable of Boolean type? What we'll do is to come and say Boolean y. We are saying the name of our variable is y and it is Boolean type, and here we said equal to true. It means the initial value is true. And if we wish, we can say Boolean accurate. We are telling the program that this accurate is the name of our variable, but we are defining the type of that accurate as what? It is a Boolean, and you know Boolean can have either true or false, but here we did not initialize without any initial value, but here we set the initial condition for that y is true. If you want to declare a character, this is what you will do. You write char here, which means character, and grade here is the name we just assume. We are saying that the variable, we give it a name grade, and this variable is of what? Character type, and here we give it initial value. You can see that the initial value is a, an alphabet. So whenever you are given alphabet, you put it in double quotes. But here, when we have values, we use what? Without any double quotes. And if you wish, you can say character scope, meaning my variable name is scope, but what type is it? It is a character. So I define my variable as scope and I define its type as what? Character type. But it does not have an initial value in this case. Then if you want to differentiate what we have seen just now, because all these 8, they are categorized into what we call primitive types. So any other type apart from these primitive types is called a reference type, and this reference type, they are defined and used by the programmers themselves. So the next thing is the constant, because you know we are discussing of two types of data. We see one is variable and the other one is constant. We define our variable as a specified location which is reserved in a computer. Now, what is a constant? In programming, when you mention a constant, you are talking of an identifier, and this identifier has a value that you cannot change during the execution of the program. That is, it is a value that have a fixed magnitude, that once you define it, you can never change it. But if you remember, I told you a variable is a space reserved. So you can put this thing today, tomorrow you can delete that thing and put another one, which means the values of variable can change, but a constant can never change in program. And this for this reason, constant is defined only once, and when you are defining your constant, it can be referred to many times in the program. Whenever you want to use it, just call its name. It will go and take that previous value and use it for you here. instead of repeating it always. So what are the ways of defining a constant in a program? How do we define constants? So for us to define a constant, there is very basic way that is used for writing a literal number or writing a character or a string into the program directly. For instance, if you are programming in C language, whenever you want to tell the program that this what I'm giving you is a constant, you write this hash define. The moment you write hash define, you are saying that whatever follows it, it is a constant value, it cannot change. So here we are saying this pi is a constant value and its value is 3.141592655 and it will never change. That is in C programming language. But in C++, if you want to define a constant, you write this const. If you write const, the program will not understand that the value that is coming is a constant and it cannot change. And we call that constant a pi2, but we define its type. We are saying it is of a floating type and the value is given as 3 point that. When you are using other programming language, if you want to define a constant, you bring the name of the constant first, you put colon, then you put constant in full, then you put colon, then you put equal to the value of that constant. But in Java programming language, all we need to do, we don't need to put anything like constant. All we need to do is to define the name of the constant. Here we said it's pi, and the type is a primitive type which is double, and we give it a value. The moment you give it a value, the Java program will understand that what you are putting here is a constant and it will never change. This is the first way to write our constant directly into the program. The second way of defining our constant is by defining what we call symbolic macro. What is this symbolic macro? This symbolic macro is a process where the programmer can define at the beginning of the source file. You define all your constant at the beginning of the source file, just as they give us in exams. Before you start, before first question, they will say take the values of this constant to be this, so that whenever you see them in any question you want to solve, you refer to that value and use it. In the same way, the programmer can define the constant at the beginning of the source file, or sometimes he can define this constant on separate definition file, separate file. So you link the two files so that whenever you want to use it, it will go to that other file and pick it. And in defining it in different files, you have to give that file a different name, and it can contain different constants which can be referred to. Ladies and gentlemen, this is the end of our lecture number 4 in Buad718, which is computer in organization. Thank you very much for taking your time to watch, and as usual, I would like to advise you to kindly take your time, carefully watch the video and try to understand the explanations. You can play it many times for you to get better understanding. In case you have any issue, any problem, you are allowed to contact me and I will do my best to explain further. You can as well contact other colleagues and other friends who understand it better and who can help you to get better understanding. Thank you very much. Until we meet in the next lecture.